Today what we want to talk about is graphing linear equations. There's three things that we need to do today. The first one is we need to take a look at what exactly makes a linear equation, how to graph a linear equation, and then graphing using intercepts. So let's go right on to the notes and we'll begin here. Now these notes are a little bit different than what is on your Google Share. But for the most part, they are very similar. So first one, graphing linear equations, we're looking at section 4.5 here. First, we have to identify linear equations. A linear equation, simply put, is an equation of a line. It can have no slope. It can go straight across, like most of our land here around Patrick Henry and Henry County. It can be vertical, going straight up and down, which means it has an undefined slope. Or it could have a little bit of a slant or tilt to it. And that is something that we'll get a look into here in a little bit more details. The first thing after that is standard form. You can see that they're in bold letters in front of you. AX plus BY equals C. A is just the value of how many X's there are in the given equation. B is the same thing, but now for the Y's. And C is a constant, so a number that's all by itself. There are no variables with it, no exponents. It's just the whole number alone. What is true here is that either A or B can be 0, but they both cannot be 0. And the other thing, too, is that the greatest common factor of our A, B, and C, our three coefficients, is 1. So there are no halves. We take out all the halves from this. They're all whole numbers. And they all can be divided by 1. So it's in the simplest form. So you're not going to see a 2, a 4, and a 6, as those three can all be reduced. So they're lowest terms, and they are all written as whole numbers, no fractions. So first, let's begin with example 1 here. It's identify linear equations. So here's two equations that we can see. We want to know if this is indeed a linear equation. So if we look at example A, down here in the bottom left-hand corner, there it's highlighted for you. 5x plus 3y equals z plus 2. So if you take a second, look back up at the standard form of ax plus by equals c, does this form in example A match the standard form up above that's bold? Well, if we look at this, we do have the 5x, so 5 would be our A with our x value. We have a 3 that acts as our B because it's with the y, equal to z plus 2. Here's the trick in this problem is this z. In a linear equation, you can only have an x and a y. So because of having this simple letter z in our equation, this is no longer linear. So our answer to this would be no. There are 3 variables. So let's shift our attention over here to example B. Again, I have it highlighted for you so you can see it. It says 3/4 x equals y plus 8. First, is this a linear equation? Again, take a little bit of time, look back up at the standard form of ax plus by equals c, and is this a match? As you look at the equation, we do have a 3/4. This would act as our a because it's with the x. We have a y, which its coefficient is 1, as there's no number in front of it, so we know there's 1y. And our c is 8. So yes, this is a linear equation. Everything is good with it. Now we just need to write it in standard form. If you remember from up above, standard form is all whole numbers, and the greatest common factor is 1. do we have all whole numbers? Well, I hope pretty easily you can look at our A coefficient of 3/4 and see that it's not all whole numbers. So if we multiply everything by 4, we want to multiply to the parentheses of 3/4 x equals y plus 8. We will get 3x equals 4y plus 32. So we did the first part. We got rid of any fractions. We have all whole number values. Now the last question is, does it look like our standard form up above? And that answer is no. Standard form has the x's and b's all on the left side, or excuse me, the x's and y's on the left side, and the c is the only thing on the right. So how do we get the 4y from the right side to the left? It's being added to 32, so we have to perform the opposite and subtract it from 32. And this is our final answer. So we can highlight this, maybe. So here's our solution. 3x minus 4y is equal to 32. So there's two examples. I have two more down here at the bottom of the screen for you. I'd like for you to take a look at these and see if they are A, linear equations, and if they are, please put them into standard form. And if you're done with the third example, example C, if you haven't already, make sure you go over and start looking at example D as well. Okay, hopefully we've had enough time to look at it, so let's talk about it here together. Example C, is it linear? It has just variables x and y, so that's good. So this answer, yes, it is. But is it written in standard form? 3, 6, and 27. They can be divided by more than just the number 1. So what we need to do is go through here, and we need to divide all three of these terms by 3. So that 3 divided by 3 leaves us with 1x. Negative 6 divided by 3 leaves us with negative 2y equals 27 divided by 3 is 9. So now we have all three terms in lowest terms, so they can only be divisible by 1, and both the x's and y's are on the left-hand side of our expression. So we are good to go. So if we jump over to example D, we have 1/4 x equals negative 7. This too is linear because we have the variables. Remember we said before that as long as only x or y was equal to 0, it was good to go. So we have a value with x, so that leaves us with only one variable that is equal to 0, and that is the y. So to get this in the standard form, what we need to do is, like the example up above, we need to multiply. And we're, again, going to multiply by 4, as that is our denominator. So a quarter x times 4 will give us 1 whole x. 0 times 4 is 0 y. And that is equal to negative 28. So with writing that 0y there, you can see that we do indeed have a y term, and that it is a 0y. So this way it looks more likely in a standard form versus seeing the original with the fractions in it. A couple things that are not in these examples that you do need to know: you can never have two variables multiplied together. So you can never have an x times a y. And you can also never have a negative exponent or a variable in the denominator. They both act as the same thing. And here's an example of what I mean here. You cannot have x to the negative first, as that is the same thing as saying 1 divided by x. So negative exponents and variables in the denominators are both no-nos. You cannot do that. Okay? That was the only example that you need to see that was not available in those first four. So move on to our second example, our second page, graphing linear equations. So what we need to do is we need to find some ordered pairs that actually work onto this graph, into this line equation. Now, if you remember before, one of your favorite sections, and I say that sarcastically, one of your least favorite sections from chapter 3 was rewriting equations so that you had a certain variable by itself. In order to graph lines, that's why we did that section in 3.8, is so that when we get to this type of problem, graphing a line, you hopefully have the tools ready for yourself that you can get this equation y equals form, and that way we can make it graphed. So we have the equation y equals 1/2 y minus x equals 1. Well, the first thing that we need to see here is that we have y and x together. So we need to get this x to go to the other side. So what we can do to accomplish this is to have 1/2 y now equal to x plus 1. Because x was a negative on the left-hand side, we were subtracting it from 1/2 y. We can do the opposite and add x to both sides to get it away from the y. Now we still have a 1/2 y. To make a half into a whole, how many halves make a whole? I hope you're able to think to yourself that yes, 2 halves make a whole. So we need to multiply everything by 2. A half times 2 is 1. 1 times 2 is 2. And 1 times 2 again is 2. So our equation that we began with, 1/2 y minus x equals 1. Graphing wise, we need to have it as y equals 2x plus 2. So down below into our table, you see I've already had that typed in here. We have an x that we're going to pick out values to plug in for x. We will find what y is based on our answer of 2 times our number plus 2. And then in the last column, we will type it as an ordered pair. When you do this, what you want to do, I would say 3 or 5 numbers are good. You want to have equal numbers on negatives and as positives. So for this example, I'm going to pick out 2 negatives. I'm going to have -2 as one example. Then I'm going to also have -1. I also want to have 2 positives so I can see what it does on the right side. So I'll make it 1 and 2. And the most important thing that you want to be able to see is what happens to our graph as it crosses the y-axis when x equals 0. So I have 2 to the left of 0, 2 to the right of 0, and 1 right on 0. So if I go back up to negative 2, y is equal to 2 times negative 2 plus 2. 2 times negative 2 is negative 4 plus 2. Give me my y answer of negative 2. So my ordered pair would be the negative 2 I started with and my negative 2 that I found as my answer for y. We go down and do this all over again. So y equals 2 now times negative 1 as I change my x value plus 2. 2 times negative 1 is negative 2 plus 2 is now what y is equal to, and I know that negative 2 plus 2 is 0. So my ordered pair is negative 1, my x value I chose, and 0, my solution. Now we do it again with 0 in for y, or excuse me, for x. So 2 times 0 plus 2. 2 times 0 is 0, plus 2 gives us an answer of 2, making our ordered pair 0, 2. We do this again, plug in 1 for x. 2 times 1 plus 2. I know 2 times 1 is 2, plus 2 gives me my y answer of 4. And I show that as my ordered pair, 1, 4. And we do this one last time. Now we're plugging in 2 for x. So 2 times 2 plus 2. 2 times 2 is 4 plus 2 gives me an answer of 6. My answer is 2, 6. So the table allows us to find out values that we can plug in for our line. We have 5 values, so if we can graph any 5 points on a coordinate plane, we should be very comfortable that we can connect the dots and make our line. So I have my pin selected. We'll use a red marker. My first point, negative 2, negative 2. I'm going to enlarge this graph so you guys can see it better on the smartboard as you're watching this video in class. Similar to what I've done before, we're just going to make every blue line that's given originally worth a half. So these red ones are worth a whole 1. Now when we get to the end, we won't be able to graph our last point. But having 4 points will be good enough to put us in the right spot. So if I go left 2 and down 2, I have my point here. Left to 1 and 0. 0 and up 2. 1 and up 4. So with my 4 points, I can now grab my line tool. And I'm going to connect from my last point through to my first point. And there's my line that's graphed. I can extend this line through. So my last point that I didn't have time to graph, 2, 6, would be right here where my cursor's at. Okay. One thing I want you to notice here, as we go, we keep going up by 2's. So for every 1 I went to the right, I went up 2. I went 1 right, up 2. 1 right, up 2. We get this because of our equation 2x, What that 2x means is for every 2 we go up, we're going to go right 1. Or the other way I said it, right 1 and up 2, because our denominator is 1. So we have this line graph, and we can look at what's going to happen because of what we're given. The other thing we can see too is that we had this 2 that was our constant. It was the whole number that was all by itself in y equals form. If you notice on our graph crosses the y-axis at positive 2. This is true, and we know it's going to be true because of the plus 2, our y-intercept. That gives us a clue of where we're going to cross, which we're going to cross at positive 2. So we have another equation for you. I'll give you some time here to work on this on your own and go ahead and take a look at it. And about 2 minutes, we'll come back and we'll do it together. Okay, hopefully you've had a little bit of time here to work. Again, if you notice our given equation, x plus 2y equals 6 is not in y equals form. So what we need to do is try to get that x away from the 2y. So we can do that first by subtracting. So we now have 2y equals negative x plus 6. We still are not in y equals form as we have to divide by 2. So if I come down to my table, I can correct this. I can divide 2y by 2 and get 1y. Negative 1x divided by 2 is negative 1/2 x. And 6 divided by 2 is 3. So my given equation I'm going to work with is y equals negative 1/2 x. And that's supposed to be a plus 3. I'm going to use the same coordinates I used before. I'll start off with negative 2. Set y equals negative 1/2 times negative 2 plus 3. Negative times a negative is a positive, and half of 2 is 1, so I have 1 plus 3, which is 4. So my first ordered pair, negative 2, 4. My next x coordinate is negative 1. Y equals negative 1/2 times negative 1 plus 3. Two negatives again make it positive. Half of 1 is a half plus 3. That's 3.5. So my order pair is -1, positive 3.5. Go to 0, y equals -1/2 times 0 plus 3. Half of 0 is still 0, plus 3 is 3. So 0, 3 is my third order pair. Next I can go to 1, y equals -1/2 times 1 plus 3. Half of 1 again is a half. Now a negative times a positive gives us a -1/2 plus 3. So 3 minus a half is 2.5. So if you look at your y's, do you notice a pattern here? I hope that you see each of these y values is going down by a half. If you look at our slope, -1/2 tells us we're going to go down 1/2 at a time. So our last one, plug in 2. Half of 2 is 1. Negative times positive is negative, so -1 plus 3 gives us 2. So positive 2, positive 2. So if I come over to the graph, I'm going to do the same thing without making my marks. There's 1, 2, 1, 2, 3. There's 4. Mark it with a blue dot. -1 and 3.5 is right here. 0 and 3 takes us to this point here. Again, 3 is our y-intercept because it was all by itself in the given equation. 1 and 2.5 takes us here, and 2, 2 is here. And if we pull out a line tool and connect our dots, because our slope is negative this time, you see our line is going down as it goes to the right. And because our slope is -1/2 instead of a positive 2, it's a little bit of a flatter slope. It's getting closer to being a straight line going across from left to right. So the smaller the slope, the less of the change that we make as we move from left to right. The bigger the number, the bigger the increase. So there are the first two parts of what we are looking at today. And now the last part, using intercepts, graphing. So we talked a little bit earlier about the y-intercept. It's the number that's all by itself when x is 0, or when y isn't the equation all by itself. The number by itself is our y-intercept. So we have these two equations. We'll take a look at both of these via the intercept format. So my first one, I need to get into y equals form. I need to subtract 4x, but because it's a negative y, I need to change all my signs. So to get a positive y, excuse me, I divide by -1. I subtract 4x over, which a negative divided by a negative turns into a positive 4x. And a positive 4 divided by -1 makes it -4. So my line that I'm going to graph to begin, this first example, is y equals 4x minus 4. So first thing that I know that I can do is I can graph my first equation, my first intercept, -4. If I plug in 0 for x, 0 minus 4 is 0, -4. So 1, 2, 3, 4. I go down because it is a negative. Now if I go back to the original equation, in place of this negative y, I want to put in a 0. So what times 4 equals 4? Well, if we divide both sides by 4, x would equal 1 when y is 0, So I can graph that ordered pair by going right 1, up 0. So now that I can see my entire graph, I can grab a line tool and connect the dots. And I can stretch it out this way as well. So there's the third way, graphing by just our x and y intercepts. So over here for B, go ahead and try this one on your own. The first time you can go ahead and plug in a 0 for x and find y, and then plug in 0 for y and find x. So let's do this. Let's have the girls, you guys plug in 0 for x and find your y. And guys, you plug in 0 for y and find your x value. So that way each person has a point. We'll put it up here together, and we can draw our line in just a little bit. Okay, so girls, when you plugged in 0 for x, 2 times what number is 6? And you should have found that to be 3. So I'm going to go up 3. There's a big dot we can all see. Guys, when you plugged in 0 for y, so that gets rid of this. What times 3 is 6? And you should have found that to be 2. So if we can connect these two dots, we can now see exactly what our line would look like. So we talked again about today going into finding out if two equations are linear, which you need to have an x and a y. One of those two can be a 0, but not both of them. You cannot have an x times a y, and you cannot have a negative exponent or a variable that goes into the denominator, as that would act as the same thing as a negative exponent. We then looked at graphing by tables. If I were you for your homework, I would only do one negative, a 0, and one positive. So that way that gives you 3 numbers to graph instead of just looking at 5 numbers. That way that'll save you just a little bit of extra time. And then the last thing we looked at was graphing by intercepts. If you would like to graph by intercepts, by all means, go ahead and do so. Whatever fits you best is fine with us, as long as you get that graph right at the end. That's at the end of the day, that's what matters to us. So you'll be getting a worksheet here from Mr. Snyder. I would like for you to take a look at worksheet 4.5 and do all of those problems and have that ready to go for tomorrow when I come back and see you guys for my trip in Columbus. Hope you guys have a good day, and bring any questions with you to class tomorrow, and we'll look at them then, and we'll see what we can do from there. Thanks.